All right, guys, now we'll go demo number 3. It's kind of seasons changing from, one demo to another from provisioning. So I'd like to focus on operations. And what I'd like to talk about is how we actually allow you to build a tool chain. Because if you think about it, the end result is that every customer has some common, tool chains, but then there are very specific things about it. So what we have here is we've combined, the workflow composer with one of our software solutions around the flow optimizer. And for those of you who are not familiar with the flow optimizer, essentially it's a visibility policy engine that listens to flows from the network, and then it allows you to actually define or predefine policies where you can take some actions on the network nodes. And overall, from a solution perspective, it runs on an SDN controller as well, because we have customers who are, who use OpenFlow, who are very SDN centric, and we have devices and network devices, which allow those capabilities. But we can also combine this with the workflow composer, where on our SLX switches, you can take some actions, based on some of the policies you define. And one example I'll give you here is, for example, think of a volumetric DDoS attack. So you get flows from your network. You're able to define certain thresholds, which I'll walk you through. And then you want to have a policy to say that if I see a well-known DDoS attack, I'm going to do something about it, such as dropping, traffic or that flow on a specific edge port on the switch. And it relates really to also the fact that time is money here, right? I mean, so many research reports in the industry highlight to basically various ranges of how much it costs for network downtime. And so roughly, even if you take about $8,000 per minute, as one of the analysts put it. And let's say if the outage is because of an operational issue or a DDoS, then then the clock is running against you. So combining the tool chain to automate everything is actually very beneficial from that perspective.
So quick question.
Yeah.
Is there parity between what you can do with OpenFlow 1.3 and NetConf as far as filtering?
So because OpenFlow is very flow-centric and you can go detailed, I wouldn't say there is one-to-one parity, but there are a lot of policies, such as dropping a flow, where actually you can do some of those things. And what I'm going to show you is by using extended ACLs through automation.
Okay.
So in this demo, what I'm going to, and this is kind of a setup where what I want to do is I have a network, and if you can see on the left-hand side, there is a SLX 9140 switch, which is typically used as a leaf or a border leaf, And the idea here is that, you're a large enterprise or you're a provider who has a lot of tenants that you're hosting, and you're listening to the flows, and this SLX switch is actually sending S flows to the flow optimizer. And whenever you see a certain predefined threat, like an out-of-the-box DDoS attack, which I'll walk you through, then the flow optimizer is going to trigger a policy via a REST API. So it's going to basically, trigger an event on the workflow composer, as I think Patrick showed you earlier in the concept of, what is a trigger and what is a workflow and what is the action. And the action will be to actually enforce a drop policy of that thread flow on the Ethernet 0/11 interface on that switch. In addition to that, as you've seen with the demos Ram showed you, you can also do the toolchain integration, where you can open a Jira ticket when you see something like that happening. So let's say if it happens in the middle of the night, you take care of it, but you document it in your ticketing system. And you can also alert your chat ops folks through Slack that, we saw a thread, it's been taken care of, and here's a link to that Jira ticket, for example. So one thing to kind of mention is that we're going to apply a workflow called drop provision, which will be triggered by the action on the flow optimizer. And this is also available as our production solution. So if you were to get version 2.1 of our flow optimizer with the workflow composer, these specific releases and the automation suite, then you can actually put this in production, and some of our customers use that. Like, so let me just switch over to the demo here. So here is the flow optimizer, and you can see that as we've been acquired, we're going through some rebranding, which takes a bit.
How about you already made it purple?
True.
So while it doesn't look purple, I put purple glasses to kind of see it like that. All right.
Yeah.
So here what you see is that I have about 1.6 gig of traffic going through my test network, and I'm using Xia to generate this traffic. And it's basically this SLX switch, the 9140. So I hope everybody can read this, because on a projector it looks really, really awful.
Can you increase the font size and determine?
Let's see.
Command plus.
Yeah, control. Let me just.
OnePlus. That sounds very Mac-y.
It is.
Control plus
there
doesn't
anything
do
else?
anything.
Change settings. Yeah, you got to change settings, and then you can.
Yeah. So change settings. Appearance.
That change button right there.
Put it up to about 16. Why?
Should I change the color? You want it green or something? Or?
I think the color's okay.
Okay.
As long as it's big.
Yeah.
Huzzah.
So
Only Windows could make an ugly font in the CLI.
Say only Windows.
So just to look on the switch, right? Because at the end of in any demo, it is the equipment that tells everything. So if I look at these interfaces, Ethernet 0/11, so I can see that the traffic is going at a line rate of 86% of the line rate's about. And then if I look at the egress interface, so what you saw on that slide was 2 Ethernet interfaces, and then so it's whatever is coming in pretty much is going out, and then so here's the interface. So essentially, when I enable the policy, what should happen is that through the flow optimizer, the workflow composer should run a workflow which will put a dynamic extended ACL on the switch to take care of a well-defined DDoS attack. So we go back to the flow optimizer. So here, a couple of things is, I also get notifications when something changes. I can see what policies are being applied, and I'll show you when that happens. I can look at pretty much all of the flows going through this network, so pretty much a picture of everything at a flow level. What I can do is I can go in profiles, and let's say, I have, so all of these profiles except the last one are out of the box. So these are well-known network volumetric attacks. So I basically take this one, and I can enable this. So typically, as a network engineer, I would enable it from day one, or let's say when I put an architecture like that. And just to walk you through this real quick, what I can do is I can define a policy where I can say, so here what I'm doing is I'm saying match any IPv4 UDP traffic where the source port is 63. If you see that flow going over, let's say 100 megs, and 100 megs is a small number, but in real life it's going to be like if I see a couple of gigs worth of a flow going for a long time, then something is not right. Something is gone. It's a threat, or something is out of whack. So then I can say, basically take some action, and I can take multiple actions, and this is where you see the mix of open flow type actions as well as netconf. So you can do quite a lot. So what I'm doing here in my policy, just for the interest of time, I'm applying a drop policy to this SLX switch on this interface, right? So this is my edge interface, and this is where I want to do it.
So wait, I have questions.
Yeah.
So this when you hit that add action drop down menu, so this looks just like Open Daylight, right? Or repackaged SDN controller or whatever. And so as you hit that add action button, there's a mix of different things in there. Does it have intelligence on the back end that says, you know, if this device supports OpenFlow 1.3 and I choose this action, then I know that I'm going to push a flow mod. And then if I choose this other thing over here, and the device does or does not support OpenFlow, I can do this as a netconf.
Yeah.
How does it know? I guess is what I'm asking.
Absolutely. So today the way we do it is that some of our switches, or actually most of our devices, support hybrid OpenFlow. Which is an advantage. So we will then, and because you can go much more detailed and depends on the customer too, right? So some customers, they still want to have that OpenFlow capability. So we would actually push those actions through OpenFlow. But there are some platforms which just don't support OpenFlow. Right. So that is what is there today. What we can also do is, as we build these workflows, because these workflows, as I said, are flexible tool chains, we can build intelligence based on topology discovery, and we are trying to do some of those things, where we can determine that, if I want to push something, what do I prefer, right? And I think we can, go more elaborate. So the idea is, rather than, basically going all out on it, is to give customers the capability and the tool chain where they have that flexibility as well.
So does it, let's say I have an environment that has no OpenFlow at all,
yeah.
but I have netconf.
Yeah.
Are there still mechanisms that you're using within here? Because one of the big advantages is the topological overview that you get from, just from having that protocol enabled and the ability for it to go in and graph all those things out. If you don't have that, is it still able to do something like use LLDP via SNMP or something to pull the topological overview?
Definitely. So we do pull some of those capabilities, and obviously the thing is there's a lot of room to actually even improve that, right? So while you do simple LLDP and SNMP discovery, you can do a whole lot more to gain better insight into it, and also so those things are definitely some of it happens today, obviously without OpenFlow, and some of it obviously there's room to grow from a discovery perspective as well.
I think it was important to call that out, just based on the fact that a lot of times it's going to be a brownfield. You're going to have a mix of things, right? And you don't want to have this beautiful topological overview over here, but I just see a bunch of boxes on that.
Absolutely,
side, right? You want to see uniform.
Yeah. And for this demo, by the way, I'm not using SDN, the controller, right? So essentially, what I have here is just a second. So let me just.
So this is going to use netconf, I guess is what you're saying.
This is using netconf. So I can either have an SDN controller, or I can have the BWC controller. And it's taking a little bit of time. So you see this green. So you'll see that only the workflow composer is actually set up.
Okay.
Just a second. I think it's a bit slow.
No worries.
Well, once upon a time, this was all going to be done with OpenFlow. My memory.
So is this a different product than StackStorm?
Yes. So this is called the Flow Optimizer, essentially, which started as an application running on top of the SDN controller. But what we are doing is we are extending it to tool chain it with our automation ecosystem.
Just a quick question, because I saw the SFlow dependency. How do you license this? Is this somehow licensed via flow number, or?
So today we do it. So today we basically license the product by total bandwidth. So right, because we tie this. So this is the intelligence with our infrastructure. Because if you think about it, it closes a feedback loop where you can listen, and then you can enforce. So we license it by total aggregate bandwidth today. So let's say if you're doing, let's say, visibility on your internet links, and you have 200 gigs of aggregate bandwidth because you have 200 gig links, just buy the 200 gig license and you're good to go.
Ah, okay.
Yeah. So this is taking a bit of time, but essentially, So what I wanted to show is basically also the fact that in the devices tab, I can actually also go and look at, which devices are registered to send SFlows and which interfaces, and, basically the fact that I'm also getting the SNMP information, SNMP V1, V2 information from those devices as well. So the other thing I also want to show here real quick is that when I'm enforcing that policy, and I think it's taking a little bit to do, to kind of come back. So I also want to show you the integration with the workflow composer. So essentially the way that call is made is there's a REST call, made from the flow optimizer to the workflow composer. So whatever flow I'm seeing, I package it as a JSON payload with, the runtime metrics of, the flow. So if it's a thread and I want to drop it, I will pass those parameters. Those parameters are received by the by the workflow composer. And I think as it was earlier mentioned, we have our automation suites. So the automation suites, they will be called, and there's a workflow called drop provision. This workflow will actually be called out. And this will basically go in action. So it's still taking some time.
So while Yousuf is bringing this up, so few things over here. It started as a separate app, but it's gonna go that part is irrelevant because this is gonna go into our automation framework. So that way it will be running with the workflow composer. But the main thing that this app is also doing is, so how you can think about the scenarios. On the internet border, it's very popular because on the internet border is where a lot of the threats come in. And over there, typically the problem also becomes for internet, let's say it's N by 10 gig links or N by 100 gig links, right? The problem also becomes if you subject everything to firewall and do the whole detection system over there, right? Or to other places, then that can be very expensive. And plus it is 10 gig, 40 gig firewall. Whereas this can be used in an inline closed loop fashion with the S-flow sampling, detection, and all of that. It can work for 1 gig, 10 gig, 40 gig, and 100 gig, and all of that, right? So that way, your detection mechanism is kind of pulled into the network, right? And then you can do layer 2 to layer 4 very easily on the network itself. Or you can create a copy mirroring and send it to any other assist system, the threat mitigation or for layer 7 advanced kind of things. Yeah.
One of the
So
things
I think
that you, just to interrupt real quick, if you even zoom out a little bit further, ignoring the licensing structure, this could also be very useful from a carrier perspective, where it's very difficult, where there is no border, everything is a border, right? So you could do some pretty interesting filtering from a carrier perspective.
We have a lot of carriers. We have data center borders where it goes. Internally, let's say, Yousuf mentioned earlier, let's say, it could be an anomaly also. Let's say misconfiguration. So the flooding happened in the network, or some other suspicious traffic, which kind of just bursted up. So for those things also, we are seeing customers, leveraging that to stabilize the network as well.
So I think we're just having an internet outage. So we'll go in pause mode and.
So we can talk in the meantime about if you have any other questions. But those are the kind of use cases that we are seeing because it's inline, closed loop, and things like that. Yeah.
And it's completely customizable. I just need to create the flow, So I just making here something up. I call flow Phil, I know Phil's watching every Monday morning the new Star Trek episode when this kicks in. I want to downgrade his bandwidth,
What?
Oh yeah, you can do that too.
So actually we have an interesting use cases. We have some customers who are going IP and over radio networks. They actually use something like that to basically mark down traffic or even rate limit or drop traffic, which is not good. Rather than going in the radio network where it's all game and they don't know what's going to happen.
I give you another example. One of the customers so had the attack coming from inside, from the server side, right? And they were thinking, scratching their head, should they go to let's say Mellanox and work out some solution on top of it? Instead, so they came and they looked at it. They're like, okay, what if we just rate limit it down, quarantine it, and sort of isolate it from the network? So it's a pretty simple one, but then it kind of worked for them, and the customer really liked it. So that's just another example of how customers are being a little bit creative to see where those problems exist, and the sensor and the detection works.
That's an important point that you just made there, right? So you don't have to just filter things. You can rate limit them, and that's so. That's an issue where if you want to avoid false positives, obviously, right? And so if you have a UDP flood, which is typically an unnatural thing that you're going to see across your backbone in gigabits per second of UDP, you can say, I don't know if that's bad or not. I can just get 10 megabits.
Yeah.
Like Phil's.
That false positive is a very important word, right? Because that's another problem. So even though like, Yousuf provides over here like the ready profiles, but then those profiles to align with the false positives and kind of remove them, the user can, once the user learns what kind of flows and data is there, the user can go and tweak them.
Right.
Yeah.
And then kind of remove or, like reduce the probability of false positives.
So in fact, to Rajiv's point, if you look here, this is a modified profile. So you can actually create a user-defined profile here, which is great. Or you can actually pick any of the learn flows from the network, and you can say, you can actually make a profile against it. So there's no shortage of tweaking things or whatever. And the other thing I would just quickly want to show is, so now we just saw that once we applied that profile, we're dropping about 3.8 gigs of traffic out of that 16 gig. So that is that modified UDP flood traffic. So you see a notification here on the top left. You also see in the non-default profiles, because this is the one that I kind of modified. So you can see what is happening where I'm seeing this flow. I'm seeing about 3.8 gigs worth of this traffic. And what I'm doing is I'm simply dropping it. And with all those actions, a lot of our customers, they buy this and they will say, initially, I just don't want to do anything. So I'll just do a none action, but I just want to see what's going on in my network. Because, when it comes to visibility, actually very few people know what's happening in their networks. The other thing is, so as I invoke this, I am also on my history tab. I basically, ran the drop provision workflow as well. So you can basically see it here. This is the one where it basically ran. And if I go back to my switch where I lost connection, just a second. So now if I look at those interfaces again, so first of all, show run interface Ethernet 0/11. That was the one where we were applying that policy as an ingress extended ACL. So you can see that this extended ACL is being applied. It's kind of runtime generated. And what it's doing is, obviously, is dropping some traffic. So if I look on the egress interface, sorry. So I can see that I'm dropping about 20% of the line rate traffic that corresponds to that UDP flow. If I go back and if I remove that policy, there's another workflow called drop unprovision, which will run and it will remove it. So the other thing is that from a policy engine perspective, I can use the flow optimizer as a policy engine and tool chain it with the workflow composer, with the automation suites, and if needed with Jira, with Slack, and so on. So it's fairly flexible from that perspective. Any questions?
Have you experimented with incorporating it with some like SIM software? Because we're talking about threat management now, right?
Yeah. So we do have some integration with, for example, some firewalls, some IDS engines, because the attack vectors are shifting more and more to in the app space. So for example, we have an integration with Palo Alto, where what our customers do is they, rather than basically growing their firewall infrastructure as the traffic grows, they will have firewalls, but then they will they work in conjunction with the flow optimizer, which will learn of those threats and drop it at the network level. Or there are scenarios where we call it a science DMZ problem. A lot of educational institutions and universities, they have this tons of research traffic which is trusted. It's coming from in their network. They don't want to inspect it on their on their security platform. So they also use the flow optimizer to bypass those paths, because essentially we can not only drop traffic, we can redirect it and do all sorts of things with that.
Yep.
So I can do the opposite if I say these characteristics are suspicious for me, please send it to my IDS, yeah?
Absolutely, absolutely,
okay.
yeah. We have actually a customer who's doing that.
So I think the action part is again very important. It does just like you said earlier, it's not just the filtering. It does like drop, rate limiting, mirroring, right? And like, at the same time, just like IP next hop, that kind of integrated actions as well.
So when you do a redirect, I'm going to take it a little bit deeper here. When you do a redirect, how are you doing that on devices that you're using?
They're not using OpenFlow, right?
Right.
Yeah.
Is it just a policy route?
So right now we are supporting drop only, because drop is we also, as we look to expand in the non-OpenFlow space, what are some of the most common actions people would like to do? So drop is something that people are using, but for redirect, we'll have to look at basically the equivalent of policy map constructs to actually redirect that traffic. Because in the OpenFlow space, we have like IP next hop and other features which are very easy and very flexible.
Well, that's why I was asking, because that's actually hard to do outside of that.
So there are equivalents. So the key thing is that your policies with OpenFlow and without OpenFlow will never be, it's like translating from French to English or whatever, right? I mean, you don't get an exact symmetrical mirror, but you can get about, let's say, 90% approximation, and for that scenario, it may be good enough.
Yeah, no, I mean, that's why I wanted to call that out, because I think, pushing something down into a brownfield network that it's very likely not going to have OpenFlow 1.3 support. But having those structures built in, I think, is really useful.
But the good thing with the solution is because it's both with the SDN controller and with the workflow composer, if you even have a network that supports both, which is what we see with our customers, because they will have Brocade equipment, which is actually an advantage where we do a hybrid OpenFlow, but everybody doesn't do it. Right. So then, an overall solution like this actually helps them in both scenarios. It abstracts their policies. Because what we've done as networking people also is we've taken a very bottoms-up approach in talking about protocols. I think when it comes to policies, I think we also have to take a top-down approach to say, how do I make them homogeneous across a deployment?
That's a good point. We think about it bottom-up, but when we execute it, it's always top-down.
Yeah.
Hey, Yousuf, and this is a really hard thing for me to do because I love the engagement and the questions and the conversation. But if we could wrap things up, because we got some other cool things we want to be able to show you, and we're running a little bit out of time.
Absolutely. Okay. So I think that's pretty much it. I'll be around, so if there are any more questions, we can definitely talk. Thanks.
Okay, cool.